Okay, let's continue talk about functions. Operations or functions. It means what? What kind of things we call operations? Usually it means what? Add, subtract, multiply, and divide. But for functions, it's different. We talk about this in 154 class. We compose them, just like a music. You compose the music, you stack up. Okay? So composition of function is this way. We compose them certain way. So you write it this way. So instead of writing f of x plus g of x, two functions, we write it this way. That means we compose one into the other. Whichever inside closest to the x first, you compose that first. Then you will plug in to another place. We call them composition of x and y, f and g at x place. Okay? So let's see what do we mean. We are doing the review for your 154 class actually. So if my x is x squared, right? My g of x cubed, its g is what? G of x is x cubed minus 2x. If we write this symbol, first f of a g of 1. What does that mean? That means whichever closest to the variable first, you find the value. Then you will put into another function. So you would do g of 1 first. So that means what? You would do this one first. G of 1 you plug in. What do you have? G of 1, right? So we already have this. But 1/3 is 1 minus 2, which is what? 1 minus 2 is -1. You stack up into another function. So then you do f -1, that would be what? It should be 1. Is that right? Oh, I wrote it wrong. No wonder. It's 7. So you stack in -1 to the 7th power. Our power is negative. Let's take a look. If I have f1, that means I stack up f into f. So you would do what? f1 first. You get a value, then you put it back into f again. So 1 to the 7th power is what? 1. Then you put it into f again, you get 1. That's how we find the composition. If I have this way, okay, if we want to find instead of number, if we say, okay, compose these two functions with x, it means this way. You plug in this for g of x, which is what? X to this one. Once you have this, you stack it into the next function, right? Okay, then what do you do? That means f is saying, whatever you give to me, whatever you give to me, I'm going to 7th it, right? 7th power. So whatever you have, you should have this thing with what? 7th power. So whatever you are given to x, you take 7th power. That's what we mean. That's all you can do. You can just leave the answer in that form. If f of x this way, that means what? You would do f of x first, right? You will interpret it inside first, which is what? Whatever x given to you, you would do 7th power, right? So then you plug in again, then f says, whatever you give to me, I'm going to do what? 7th power again. So whatever you have, you are going to do 7th power. Right? So whatever you are given, now it's the 7th power. What is 7th power on 7th power? Power on power, power property. So shorthand writing, how many x's you have? X7, 7 of them times 7 times. Total, you have what? 49 of them. Okay? So, let's see. Next one. If we have this situation, is fraction. Okay? We are on your page 4, right? So g of x is this. So we say first, find a, f, g of x. That means you do the g of x first, then you put into f and see what happens. So you always rewrite it so you know what to do, right? That means we are going to do that first. That's the square root of x. Right? G of x, say whatever x you give to me, I'm going to square root it. Then you put it into f. F says what? Whatever you give to me, I'm going to plus a and divide whatever is given minus 1. So the things is given, right? Whatever is given, you are going to do what? Plus 8, then whatever is given, minus 1. That's what you are going to do. Now, take a look. What is given? This guy is square root of x. Okay? So, that will be your final answer. If we have g f of x, what do you need to do? You do the f of x first, right? Which is, that's g, x plus 8, x minus 1. F of x means whatever x is, f would be this one. Then you stack it into the g. G says what? Whatever you give to me, I'm going to do what? Square root it. Right? So whatever you give to me, I'm going to square root it. That's what I say. So whatever you give to me, I'm going to square root it. Right? So that's how you plug in. That will be what? X plus a, whatever is given, you will put into the square root. That means same thing. Okay? So what happens if I say find the g of f of g of 4, it means what? You would do g of 4 first. G of 4, you take a square root of whatever is given. What is square root of 4? Which is 2. Then you plug into the f. That would be 2 plus a, 2 minus 1. That would be, you will get 10. Is that right? So let's take a look. If g of 1, let's take a look of that. So what is g of 1? So you do g of 1 first. So you plug in 1 to the g, means square root of 1. Is that right? So square root of 1 is what? 1. So you have this. Then you put it into the f. F means what? Whatever you give to me, I'm going to plus a divided the given minus 1. So you have 1 plus a, 1 minus 1. Okay, what happened? 9 divided by 0. Can we have a denominator 0? Not really. So, and you can say undefined. Some places say doesn't exist. Okay, use that symbol. So let's take a look. If g f of 4, right? So we do f first. Whatever closest to the number, the variable, you do it first. So G of 4, F of 4 means what? 4 plus A, 4 minus 1. So 4 plus A, 12 divided by 3, actually is 4. So you plug in to the G. So what do we have? G says square root. So that's how you get your answer. Then let's take a look. This one, G, F negative 2. You plug in F first. So what do we have? Negative 2 plus A, negative 2 minus 1. So that would be 6 divided by negative 3. That would be what? Negative 2. G of what? Negative 2. Then you use G negative 2, plug into G. Then inside is what? Negative 2. But for square root, then cannot have a negative number in the radical numbers. So you say it doesn't exist or not a real number. In pre-calculus, okay, in pre-calculus, we start to use imaginary number and not a real number. Okay, let's take a look how we actually use it. And some example here. Okay, say a planning commission estimates if a city's population P, thousands of people, its daily water usage would be such function. Okay, we call water usage by P thousand people. So your water usage is derived from how many people using it. So people using it is your X. The usage, water usage, would be your W, right? So many gallons. So the commission further predicts the population in T years would be this way. So population, they say this way. So what does that mean? P is like your Y population, then start from X is your T according to the time. Population according to the time. Y according to X. P according to T means population will be depicted by the time it grows, right? Say then it grows and you use more water. So they want you to express the water usage W as a function of the T. So what are they talking about? So they say water usage is according to what? How many people, right? Then they did a calculation, they use their data, for years they expect to be that way. Whatever the population is, you will grow how much water usage will be used. So now they want you to do what? Express the water usage. Water usage is according to the time, right? As time goes by, more water will be needed. So they wanted to do prediction. So more time has gone by, then you have more population, you will have more water usage. So they say after 10 years, okay, express water usage as a function of T, and the number of years from now, find the water usage 10 years from now. So we can do this way. So if method 1, we say, okay, let's see, population 10 years later, right? So you plug in. So that would be plug in here, so plus 2 times 10, they will expect you have more 80,000 people instead of what? from 60,000 to 80,000 after 10 years. Then after 10 years, water usage would be 80,000 people. Then you plug in here, right? Would be 30, use this formula they give to you, 80 to 1.2. Use your calculator. So that would be what? 5765.397283, something like that. So it's about what? 565 thousands, because the unit is thousands gallons. That's one way. Okay? Another way is we use the what? Composition method we just learned. So we want to find out the population is according to the T, then, right? T costs the population, then population costs the water usage. So you plug in, by doing that, you will have what? So W, P of T is this one, 6 plus 2T, right? Then what do you do? Then we have this. Then you plug into the W, the method we just learned, it should be what? That's your P, right? Whatever P is, you will do 1.2 power. So that would be 30 times what? 60 plus what? 2T to the 1.2 power. Then we want to predict 10 years later, so you can just directly plug in what? 10 here. Then if it's this way, 10 years later, you will just plug in like this. 2 times what? 10 to the 1.2 power. So it's when you put it into the calculator, you actually find out it's, you will get the same answer. Okay, so we talk about how functions operate. Then we are going to this page 4. Then we are going to review another portion called transformation of functions. Then review for what you have learned in 154A class again. We are on the page 5. Continue with the functions. So we explain what are functions. We talk about the concepts. Then we talk about operations. So concepts are for functions, they are from point A to point B, or from point X to point Y. And for operations, we are talk about composition of functions. How do we stack up the functions? So from point A to point B, and from point X to point Y. Y is function of the X. In turn, in the business world, we say from now on, as the time goes, the profit is the function of the time. So from time to the profit. So we talk about functions. Now we go back to the basic functions, what kind of function they are. Then we write in the math form, then we use in the business world. So let's go through basic functions we have learned. So we learned from 154A then review. This week we are review those functions. So we have those functions, and basic one, linear, constant function, and identity and absolute value. Then we talk about quadratic. So linear function, look your page 5. So linear function is like, for constant one, you have f of x equals some number, say 5. Then identity function, we talk about x map to x. Absolute value function is the absolute value. Then let's look the graph. How do they look like? How do they behave? So we can apply to the business world. So we go through the basic first. So function of phi, you can use t-table and everything y. So f of x actually is your y, right? So if you look, you can do the t-table, that's your 5 for any x. So for constant function, it will look like that. Then f of x equals x. So 1 to 1, 2 to 2. So it will look like this. It's on your paper. And absolute function, if 1 map to 1, negative 1 map, still map to 1, right? Absolute value. So you have 0 map to 0, 1 to 1, 2 to 2, negative 1 to 1, negative 2 to 2. So it will look like this. And so for quadratic function is we do the basic one, which would be what? F of x equals x squared, or f of x cubed would be x cubed, right? And reciprocal function would be x to the inverse and 1 over x. It's on your paper. Reciprocal squared would be 1 to x squared. Rule would be what? F of x equals square root of x. Cube rule would be what? Cube of x. So those are basic functions. It might move around, shift up and down, left and right, right? So for quadratic function, also you can go to the website and easy to graph. Try it. Also, you can use calculators. So for square quadratic function in your 154A class, so it will look like this, symmetric, right? Then cube rule function, it will look like this. Then for square root function is what? Sideways parabola. Is that right? So if you have a function of square root of x, if x is your time, as time goes, then your profit may level out to some point. So if x is your time, this is your profit. Profit is according to the time. So profit is the function of the time. If the graph looks like this way, then that means it will level out to some point of time. So, and if cube root of x, the graph will look like this. So just give you a basic idea how they looks like. For the reciprocal, you can just use the website to graph and take a look. Figure out how to use graph the functions. If you have questions, and call me or text me. We can go over the phone. So reciprocal looks like this. This is your 1 over x graph. Okay, and for the reciprocal squared, it will look like this. So this is just your basic function we are reviewing. Also, take a look the page 6. On page 6, you have all those graphs showing to you. Then you can just, if you don't remember, just use a teacher and try to figure out how to plot those. Okay, so you have parabola. Parabola equals y equals x squared, and if you have y equals negative square, this is y equals x squared. If y equals negative x squared, it means what? It flip upside down. Then if y equals x squared plus 5, what will happen? Everything that's your square, then everything move up to 5. If y equals x squared minus 5, it moves down like that. So that's on your page 6 for you to review. So that's your section 1.2.